In the last episode, our experimental physicist Dan talked about how we integrate light microscope and a cryogenic sample holder into existing FIBSIN systems, which allows simultaneous coincident imaging with three beams: electrons, ions, and photons. In this episode, my colleague Keith is going to tell us the story about designing the new transfer mechanism to address the shortcomings in the traditional cryosample transfer workflow. Now he's working in the lab. Let's go get him. Hey Keith!
Hi, I'm Keith. I'm a junior mechanical designer at Delmic VV. I've been working on the ENSEL system for the past 2 years, alongside some of our other cryo and CL systems. We found that in traditional cryosample transfer workflows, there was always a significant risk of damage due to contamination or moisture, as well as possible devitrification if the sample was not kept below a certain safe temperature. As soon as a prepared sample leaves a liquid nitrogen bath, it has to be transferred through ambient air and pressure, and there's always a very limited amount of time before the sample will inevitably warm up or become contaminated. We found this experience frustrating, and it could lead to the loss of carefully prepared samples. When preparing a sample in liquid nitrogen, the challenge is that the presence of liquid nitrogen makes it very difficult to achieve high vacuum. In order to transport a sample from liquid nitrogen to the high vacuum of an SEM, the sample must first leave the liquid nitrogen bath whilst the nitrogen is still in a liquid state. The moment it leaves the nitrogen bath, it is no longer actively chilled nor protected from ambient air by nitrogen gas. In order to address some of the shortcomings traditionally inherent to this workflow, we designed a new transfer mechanism on the ENSEL. Our transfer mechanism features a load lock system where the sample preparation slusher can be directly attached to, allowing the transfer of a sample out of the nitrogen bath and directly into a moisture and contamination-free environment. During the sample transfer out of the liquid nitrogen, the sample is seated inside a cold table, providing significant cooling capacity to ensure the sample remains vitrified and dramatically increasing the amount of time you have to safely perform your transfer. Once the sample is lifted out of the nitrogen and into the safe atmosphere of the load lock can rapidly achieve high vacuum and allow the pressure to be transferred in and out of the SEM. With this improved workflow, your samples will not be exposed to ambient air or moisture and will remain vitrified for an extended amount of time. I look forward to the improvements that our transfer system can bring, meaning researchers will no longer have to worry about contamination or devitrification of their samples, allowing for a safer and easier workflow and offering higher yields. If you want to know more about the other features we're working on in the ENSEL project, stay tuned for future developments.